Find the arc length of one arc of the cycloid generated by the circle of radius 2. As we wheel this circle around a straight line, a point on the circle will map out this path, and we're looking for the length of one arc, which is the length of this path. We saw that the cycloid was parameterized with x equals r t minus r sine t and y equals r minus r cosine t, where r is the radius of the circle. Thus, x equal to t minus 2 sine t and y equals 2 minus 2 cosine t. Using the arc length formula for parametric equations, we would need x prime of t, which is f prime of t. The derivative of 2t minus 2 sine t is 2 minus 2 cosine t. We would also need y prime of t, which is g prime of t. The derivative of 2 minus 2 cosine t is 0 plus 2 sine t. To set up the integrand for the arc length in parametric equations, we would need to square both f prime and g prime and add them up. F prime of t is 2 minus 2 cosine t. G prime of t is 2 sine t. This is 4 minus 2 times 2 times 2 cosine t is 8 cosine t plus 2 cosine t squared is 4 cosine squared t plus 2 sine t squared is 4 sine squared t. But 4 cosine squared t plus 4 sine squared t is 4. Thus this is 8 minus 8 cosine of t. The arc length is the integral from alpha to beta, the square root of f prime of t squared plus g prime of t squared, which we simplified it to 8 minus 8 cosine of t. We should always evaluate and simplify the argument of the square root before we plug it into the formula, just so that we can save time. The lower limit of integration is alpha and the upper limit of integration is beta. In this case, the cycloid is parameterized with the parametric equation x and y, with the parameter interval goes from 0 to 2 pi only. Even though the length of the horizontal straight line is 0 to 4 pi, but the parameter go from t equals 0 to t equals 2 pi only. Thus, the lower limit of integration is 0 and the upper limit of integration is 2 pi. We then factor out 8 to obtain 2 root 2, the square root of 1 minus cosine of t dt. This is 2 root 2, the integral from 0 to 2 pi, the square root of 1 minus cosine of t dt. We have encountered this integral when we did trigonometric integrations, but just to remind you that 1 minus cosine of t can be rewritten as 2 times 1/2 of 1 minus cosine of t. This is 2 times, this will give us sine of t over 2, the quantity squared. This is the double or half angle formula. This is good because the square root of 1 minus cosine of t is now the square root of 2 sine squared of t over 2, which is the square root of 2 times sine of t over 2. For t between 0 and 2 pi, sine of t over 2 will be non-negative, so we don't need the absolute value. This integral is now 2 root 2 times the square root of 2, the integral from 0 to 2 pi of sine of t over 2 dt, which is 4 times the antiderivative of sine of t over 2 is negative cosine of t over 2 times 2. Evaluate from 0 to 2 pi. This is minus 8 cosine of t over 2. Plug in 0 to 2 pi. We have minus 8 cosine of 2 pi over 2 minus cosine of 0 over 2. Cosine of pi is negative 1 and cosine of 0 is positive 1. This is minus 8 times negative 2, which gives us 16.